going to talk about today is modeling data either as a linear function, which as you recall is a line and has the equation form y equals mx plus b. We have a quadratic function, which is, as you recall, a parabola, which has the form y equals ax squared plus bx plus c, or an exponential function, which looks like this and has the formula y equals a times b of x. So we have these three functions, and we're going to take some real-world data, and we are going to try and figure out which one of these models would best fit the data that we have. And this is what researchers actually do when they are modeling real-world data. And so we'll do this, I can do this in different colors, and so I'm going to make a nice little graph here. And we'll do A, B, and C. And here we go, we will do A in pink. So I have the point 1, 3, the point 0, 0, the point negative 3, 3, the point negative 1, negative 1, and the point negative 2, 0. Now, when you look at the points that we have, which of these three function types do you think that we have? Okay, Nick? Quadratic. This is quadratic. All right, so when we look at this, it does look very much like a parabola, and we would say that this particular set of data has a quadratic shape to it. Okay, let's pick out a new color. I'll go to purple here, and we're going to graph the next set of data. And I've got the point 0, 2, negative 1, 4, 1, 1, and then I have 2.5. Okay, what do you think about this? Liddy? This is exponential. All right, this is not in a straight line, and it's not a parabola shape. This is exponential, and this function is going to look like this. So we would say that this is exponential. And lastly, my last set of data, how about if we go to a nice light blue? So I have negative 1, negative 2, 0, negative 1, 1, 0, and then I have 3, 2. So what kind of function do you think we have here based on its shape, Kevin? This is linear. And so we're going to write that in here. Linear. All right, so now the next thing we're going to do is we're going to try and do the same thing, but we're going to try and do it without graphing. So here's a linear set of data, a quadratic set of data, and an exponential set of data. Now notice how the numbers change if you have a table of values. So with a linear set of data, as the x value goes up by 1, the y value goes up by one specific amount. All right? In an exponential model, as the data value or the x value increases by 1, the y value actually multiplies by a same number. All right? Now in quadratic, neither of those two things is true. And so we look at the increase in the y value. See this increase? And if we look at how the increases are changing, we notice they go up by a constant value. So what we're going to do is look at a set of data that we have below, and we're going to see which of these situations that we have. So let's go back here to the regular pen. These are all going up by 1, right? The x values here. And if we look at the y values, what's happening here? So would you agree this is going down 4, down 4, down 4, and down 4. So which of these three types of functions do you think that we have here? Liddy?
Linear.
This is linear. All right, let's go over here to example B. This is going up by 1, up by 1, up by 1, and up by 1. All right, what's happening as we're going from here to here? Allie?
Negative 0.25.
We're going down 0.25. We're not multiplying by anything because 0 times anything is still 0, and we don't have that. So we know it's not that. So we're going to have to do how much we're going up or down. So we're going to do the same thing from here, and we're going down 0.75. And as we go from here to here, we're going down minus 1.25. And from here to here, we're going down, I think, what, 1.75? Okay, so now let's take a look at this. Go out here, whoops, let's scoot the camera over a little bit, and let's take a look at round 2 here. So this is going down 0.50, right? And this is going down 0.50. And this is going down 0.50. So which kind of function do you think that we have in this particular situation? Mahana?
Quadratic.
Quadratic. And we've got one last example at the bottom of the page. So this is going up 1, up 1, up 1, up 1. What is happening as we go from this point to this point? Molly? We're multiplying by 2. So this is times 2. This is times 2. This is times 2. And this is times 2. So what kind of model do we have in this particular situation? Molly?
Exponential.
This is exponential.